Okay, this is our second video on how we integrate and differentiate inverse trig functions. Now, last video we looked at what we got, how we differentiate an inverse trig. So we're going to look at the reverse process of this. So we know from the last video that if you differentiate sine to the minus 1, you get 1 over the square root of 1 minus x squared. So also, that means if you differentiated sine to the minus 1 of a with sine to the minus 1 of x over a with respect to x, you will get, bottom line is going to be fairly similar. It's going to be the square root of 1 minus, instead of x, is going to be x over a all squared. And then top line, this is you differentiate with respect to the angle bit, and you'll get 1 over a. So what you actually get is, if you bring that a onto the bottom line, that's what you will get. So that means if you differentiate, if you multiply in then by this, how you get from this line to this line, you multiply in by that a, it goes inside and becomes a squared. So 1 times a squared is a squared, and x squared over a squared times a squared is just x squared. So that's how we get to this result here. So the big thing then is, hence, if you integrate 1 over the square root of a squared minus x squared with respect to x, you will get sine of minus 1 of x over a, and then remember your constant of integration. So that's the way it is written in your formula booklet. Okay, next one, and we'll look then at our integrating tan to minus 1. So first of all, differentiating tan to minus 1, if you differentiate tan to minus 1, remember what you get is this. That means if you integrate, if you differentiate tan to minus 1 of x over a, you'll get a similar thing, but it's going to have 1 over a on the top line, and on the bottom line it becomes 1 plus x over a. Now we could bring that a onto the bottom line, the a that's on 1 over a on the top line, bring the a onto the bottom line, and that's what you're going to have then. You're going to have this, and then if you just multiply, take a common denominator, first of all, of a squared on that bottom line, and you can see that's what you're going to get. And then if you multiply in by the a, you will eventually get over to here, and then you've got 1 over a squared plus x squared over a on the bottom line, and then just reciprocal that, and then that's what you will get. So hence, and this again, the result that's given in your formula booklet is the integral of 1 over a squared plus x squared, integrated with respect to x, is 1 over a inverse tan of x over a plus c. Okay, so those two results are what we are going to need to use in these questions. So I was just showing you where the result comes from, and then we're going to use these to do these questions. So we want to always try and get it in this form, and then it's dead easy to do. So if you can get it in that form, it is really a piece of cake. No problem at all to us. Very, very easy questions. Just getting it in that form is maybe the only trick. So the first thing, write down their question as given. And that's not quite in the form that we want. So what I could do, first of all, is I could take a 4 outside my integration sign, and then I'll write that as 1 plus x squared plus, and the square root of 16 is just 4. So that's going to be 4 squared dx. And then if I integrate that, you're going to have 4 times 1. So my a is clearly 4 then. So 1 over 4 tan to the minus 1 of x over 4, then plus your c, which is tan to the minus 1 of x over 4, and then plus your c. Okay, b, similar idea for b. First of all, I'll just write down the question again. It was 2 over 36 plus x squared dx. First thing I'm going to do is take a 2 outside, so it's 2 upon integral. I'll write that as 6 squared plus x squared dx. So clearly my a is 6 in this time, so it's going to be 2 times 1 over 6 times tan to the minus 1 of x over 6 plus c, which is going to be 1/3 times tan to the minus 1 of x over 6 plus c, and that's it for that example. Okay, the next one we're going to look at involves this identity, or this integral on the bottom line, again given in your formula booklet. So you want to get everything in the form square root of, 1 over, integral of 1 over square root of a squared minus x squared. So we're pretty much there for this one. This one just shows how we use it when we've got our limits. So let's just write down the question again. It was integral from minus 1.5 to 0 of 1 over the square root of 9 minus x squared. So if we do that, clearly your a is 3 in this one, so square bracket, it's going to be sine, so minus 1 of x over 3, and that's between minus 1.5 and 0. So it really is, make sure your calculator's in radians mode, and it really is just a matter of putting this in to your calculator. So put in the 0 first of all. You're going to have sine to the minus 1 of 0 over 3, which is just 0. And then next one, put in your minus 1.5, so that's going to be, I'll just write it in as minus 1.5 over 3. And when you put those in, you're going to get a 0 minus a minus pi over 6, if you have your calculator in radians mode, and that's just 0 minus pi over 6, which is just pi over 6. And that's it done. So a nice, quick and easy bit of work there.